Let's talk about everybody's favorite type of word problem, mixture word problems. Mixture word problems are the ones where you will have some amount at 3% plus some amount at some percent is equal to whatever final mixture you're trying to get to. We're going to follow a kind of a step-by-step way of breaking down these word problems. We're going to ask, what are the parts that we're putting together, and what is the total final mixture? All of the parts will be added together, and then the final mixture will be on one side of the equation. So let's jump into the first problem so we can kind of break it down and see what's going on. All right. Our first problem, how many milligrams of metal containing 45% nickel must be combined with 6 milligrams of pure nickel to form an alloy containing 78% nickel? Let's see. So, we're going to look at what we have for our first part. Our first part is some number, we're going to call it x, some number of 45% nickel is being combined, so added to 6 milligrams of pure nickel. Pure nickel means it is 100% to form an alloy containing 78% nickel. What is the final mass? We only have a percent. We don't know how much it is. Well, how much it is at the end, or how many milligrams at the end, is going to be our 6 milligrams of our pure nickel plus however many we need to add over here. So this will be 6 plus, not 6 plus 6, 6 plus x over here. Now, when you're doing these mixture word problems, make sure you convert your percentages into decimals. And the way you do that is you take whatever or wherever the decimal is, and you're moving it to the left 2 spaces. So this now becomes 0.45x plus 100% times 6 is going to be 6. This turns into a 1. 1 times 6 is 6 is equal to 6 plus x times 0.78. Now, we do this distributive property to figure out what this side of the equation is, isolate x, and solve for our variable. So this multiplication I cannot do in my head, so I am actually going to do this on a calculator. We have 0.78 times 6 is 4.68, and that's going to be plus 0.78x is equal to 6 plus 0.45x. Now, just like any other linear equation where we have x, we're going to put all the x's onto one side and all of the constants over onto the other side. So we'll subtract 0.45x from both sides, minus 0.45x, and that will give us 0.33x over here. And we'll subtract 4.68 from both sides, and we will wind up with 1.23 on this side. Finally, to find x, we need to divide both sides by 33. So we're going to divide this by 0.33, my apologies. Divide this by 0.33, and we'll have x is equal to 4 milligrams. That is the unit that we were trying to find. And this is our final answer for how many milligrams of nickel containing a 45% nickel must be combined with the pure nickel to make the mixture we're looking for. For this word problem, whenever we do our percents, I'm going to go ahead and convert them directly into decimals so we can kind of skip over that step. Let's take a look at this one. Emily mixed together 9 gallons of brand A fruit drink and 8 gallons of brand B fruit drink, which contains 48% juice. Find the percent in brand A if the mixture contained 30% fruit juice. Okay, so our first part is the 9 gallons that we don't know the percentage of. So we have 9 gallons times some unknown percent plus 8 gallons, that is 48%. And then our final brand, or our final mix, we'll call it brand C. Might as well because we have brand A, brand B. So brand C will have 9 plus 8, 17 gallons, and that will be at 30% fruit juice. So let's go ahead and do our multiplication, simplify everything out, and isolate this variable. We actually did not put a variable in there. We put in a question mark. Let's put a variable. X. All right. Let's do our multiplication. Again, this is multiplication that I can't do in my head. So let's do 0.48 times 8 is equal to 3.84, and we have 17 times 0.3 is 5.1, and this will be 9x. Subtracting 3.84 from both sides, we get 9x is equal to 1.26. Finally, dividing both sides by 9, we get x is equal to 0.14. Now remember, we were looking for a percent in our answer. We're finding the percent of fruit juice in brand A. So we're going to convert this decimal back to a percent by moving our decimal place twice and get 14% for our final answer. For our third problem, we have 16 pounds of brand M cinnamon made by combining 12 pounds of Indonesian cinnamon, which costs $19 per pound, with 4 pounds of Thai cinnamon, which costs $11 per pound. Find the cost per pound of the mixture. So we're not working with percents in this one, we're working with dollars. We're still going to follow the same process. We're going to multiply the pounds of cinnamon mixture times the cost instead of multiplying the amount times a percent. So our first one, we have 12 pounds times $19 per pound. That's our Indonesian cinnamon, and that's being added to 4 pounds that cost $11 per pound. And that's our Thai cinnamon. And this is finally equal to 16 pounds of some unknown cost. For this one, multiply everything out, isolate our variable, and that will give us our cost. So 4 times 11 is 44. 12 times 9 is 240 minus 12 is 228. And that's equal to 16x. Add these together, we have 272 is equal to 16x. And then we divide, and I can't do that division in my head, so let's do 272 divided by 16 is equal to 17. And that is our final answer. Well, it's $17. We can't forget our unit. Our final mixture will cost $17, which makes sense, by the way. We're mixing $19 per pound with $11 per pound. We should come to an amount that's somewhere in between those. And we're mixing more of the $19 per pound than the $11 per pound, so we should be closer to the 19. So this answer does make sense. We are in between 19 and 11, and we are closer to the 19. Let's take a look at our final problem. A metallurgist needs to make 12.4 pounds of an alloy containing 50% gold. We already know this is our final product or our final sum at the end, so let's do that. We have 12.4 pounds at 50% gold. He's going to melt and combine one metal that has 60%. So, yeah, let's make that 0.6. And another metal that is 40% gold, 0.4. How much should he use? We're missing two separate values here. So let's call our first one X. And should we call our second one Y? No, don't do that. We don't want to add a second variable in here if we don't have to. What we're going to do for the second one, we know that however much this is plus however much this is makes 12. So X plus this amount is equal to 12.4. So that means this amount is the same thing as 12.4 minus X. Oops. 12.4 minus X. And now we have everything plugged in. Let's do our multiplication. So let's see, 12.4 times 0.5 is going to be 6.2. And this is going to be 0.4x. And this one, well, we'll definitely have negative 0.6x right there. And that multiplication I can't do in my head. So 12.4 times 0.6 is 7.44. Now we isolate our variable x. We'll have negative 0.2x when we combine these like terms. And then kick this over to the other side. 6.2 minus 7.44 is negative 1.24. Finally, divide both sides by 0.2, by negative 0.2, divided by, we have negative 0.2 equals 6.2. So this means, remember where our x variable was. It wasn't here, but x by itself was up here. This variable x is equal to 6.2. That means that this one is 12.4 minus x, or 12.4 minus 6.2, which is also equal to 6.2. So this means we need 6.2 pounds of the 40% mixture and 6.2 pounds of the 60% mixture to make 12.4 pounds of the 50% mixture. That's all I've got for you today. If you found this video helpful, consider liking and subscribing. If you have a topic you want me to cover in the future, leave it down in the comments below. And as always, have a fantastic day.